99%. So this is utilization is 10%. This is 99%. It's not balanced. So 80% of them, 90% of them are idling. So it's critical how to balance such a job. Also, data splitting. If the data is clearly divided into several blocks, several groups, it's much easier. Okay? Then, which means this job, this thread and this CPU use the disk 1 and this one is disk 2. However, if they access each other or is share the data, sometimes one of the data will be locked during the processing, the other cannot access, cannot update, something like that. So you need to consider such a data splitting. What about, after this one I explain the concept picture. Data dependency. Okay? So between the thread, you need to, if you need access the, if you have the shareable data, it's more complicated. Also testing and debugging are complicated. So anyway, our goal is to increase the terrorism, okay? But you need to consider concurrency, same time, concurrency control. There are different types of the system architecture for this one. Memory. So it's a disk drive, and this is a CPU, and this is the memory. So they do not share any computer resource. They are connected through the network. This is called shared nothing system architecture. So when you build a cluster with a shared nothing system architecture, you can put as many nodes as possible. Then all data should be distributed and their job should be separated independently. Okay? You can get the maximum, you can get the high utilization of the system, but the job is very, very limited because they do not share any data, they do not share any resource, just independently work for this one. For example, this is the LA, and this is the New York, and this is the Dallas, the population or customer. So I'd like to count the number of customers in LA from this one, in New York from this one, in Dallas. There may be no problem. You can do the parallel processing. Okay? What if there is the item data, but you need to join the customer end? At that time, it's more complicated. At that time, you cannot get the full benefit of the shared nothing. So to address this problem, sometimes you can share the memory along the different nodes using the memory channel. They do not share the motherboard, but they share the memory data through the very fast memory channel. Okay, so this is called shared memory. Or sometimes you can share the disk using the SAN network, SAN structure, storage area network. You can share the data. So shared disk architecture, shared memory architecture. But multi-core processing is in one CPU chip. There are multiple cores. It can be considered regarded as the different CPU. It's not like the same as the SMP, symmetric multiple processor, but almost the same performance as the such as SMP. So they can process different threads of the instruction simultaneously. So we will get the benefit of the such a multiple the parallel processing using thread. There are two types of the parallel parallelization. One is data, another one is task. Data, I already explained about in that example. And what about the task? Task is from one program we can separate by the job. Like this is a printing. This is the reading image. This is communication. If you have the separate task, so you can do the task parallelism. But here, so in the single core system, you definitely need to share the CPU resources, time sharing. But in case of multi-core, definitely we can assign specific task to indicate the task to the specific core. Then we can get the benefit of them. How much we can increase such a performance? There's an Amdahl's law. Amdahl's law is there might be a maximum boundary, upper boundary of the speed up. How can we find such a boundary, maximum speed up, when we have the n number of core or n number of parallel the hardware? At the time, S is the serial portion, which means even though you are doing the parallel programming, not all instruction can be parallel. For example, second degree parallelism, 3 parallelism, you cannot make entire program 100% parallelism. Some part should be serial, sequential processing, and this part. So what is a percentile of such a serial single single thread processing? So for example, 25% or the 50%, which means in case. So that is the S. So you can see first S is the inverse, which means the higher portion of the serial processing, the lower speed. But this one is the opposite, but is the minus and n. So for example, if your application you implement the parallel programming, it's 75% of them parallel, but 25% is a single thread. At the time, you can get, when you have two core, you can get the 1.6 times. It's not 2 times. Because of you have the serial portion of it. So in ideal case, which means we have the unlimited CPU resource. Even though ideal case, unlimited means it will be go to 0, right? This part will go to 0. So it's 1 over S, which means it's the inverse of the serial portion. For example, 25% is 25% 1 over 4. So which means 4 times. Even though you have unlimited CPU resource, you can get only 4 times speed in parallel programming. That is Amdahl's law. So user thread is mostly managed by the user level. This is true actually. The operating system nowadays, many of the operating system pursue microkernel, which means operating system doesn't want to involve user level processing or user level architecture. Which means, for example, we will see one of the good example is a deadlock situation. There are actually a lot of deadlock situation in our computing, your computer or the laptop or whatever, but operating system doesn't want to interfere such a deadlock situation. It's your problem, okay? Because it's more complicated. It takes a time to solve that problem. So user need to handle such a thing. So, for example, user level thread is your job. Your application can create more thread or whatever, but the system doesn't want to involve such a thing. For example, the Java thread or Windows thread. But kernel level definitely is supported by the kernel. In other words, operating system. Okay. Each system architecture has their own, very importantly, because the thread is one of the ways to speed up your system with the software operating system level. So they each and every vendor propose their own the kernel thread. So there are two groups of the thread. One is the user thread and another one is kernel thread. When you use the multi-user thread and multi-kernel, that is called many-to-many, the multi-threading model. Which means user thread can request the system call, then one of available kernel thread will take the job. Okay. Also, you can have the many user thread and one single kernel thread, which means even though you have the multiple user thread, you cannot get the full benefit of parallelism, but kernel thread will take care the one by one. Vice versa, when you have the, sometimes you can have a multi kernel thread but single user thread. So this user thread will request the job of the system call, then one of the available kernel thread will take care of it. So this is a many to one. So we have the many user thread, but the one the kernel thread. Okay. If one of the problem of such a model is the one user thread is request the system call to the kernel thread, but it's blocked or it's hanged, something problem, and all thread will be stopped. That's a problem. So Solaris green thread or the GNU portable thread is using is simpler, right? It's much simpler because it has only one kernel thread, so it can process one by one for user thread. So it's much simpler the architecture. One-to-one is a dedicated one, so one user thread and the dedicated kernel thread whenever it requests. Okay, you don't have to manage such a thing, just allocate, but it needs more resource in the operating system. Many to many, so we don't know which kernel will take care of the user thread. So you need to manage such allocating the user thread request to the kernel thread. So Windows, the thread fiber is this kind of the example. But nowadays, most of the operating systems support mixed hybrid the model. So if the user thread, there is a user thread that is critical, you can make the dedicated kernel thread. Then the others, if that is general, you can use the many-to-many. RX, HP, 364, Unix, many of them are using such a mixed thread. So how can you find, or how can we do such a thread programming? There is a thread library in your operating system or the system program, you can find it. So like the pthread is, even though that is the specification standard, so operating system implement such a thing in operating system level, you can code such a library to make the thread program. You don't have to worry about the kernel level library where the kernel programming is implemented already in your operating system. So pthread is one of the popular thread programming in Unix or Linux system. Also, probably the Mac OS X is based on the Linux system, so they use the pthread. Actually, the name itself, the POSIX is a standard name. The IEEE, the 1003.1c API. So they specify to use the POSIX thread, you need to use this data structure. Then implementation is quite easy. Just follow their instruction specification. So this is an example of the P thread, the thread library. Okay. So you can define the thread identifier. Okay. Then you can create the thread. Right here. Okay. Then make it learnable. Okay. So that is after you allocate the specific area and the memory for the thread, then you can make it learnable. Just like after you fork then exec, you can make the thread learnable. Windows. This is an example of the Windows and multi-thread programming with the C. Java is, frankly speaking, I did thread programming with only the Java, not for the C and the P thread. I just saw the source code. So Java, I think that you already did in your Java. I think OP use the Java, right? What program language you use in the OP class? C++ right now, so it's changed. What about the 101, 102?
Yeah, Java.
It's a Java. So did you learn the thread programming in your 101, 102?
It's a Java class.
Yeah, so I think it's a basic, one of the basic programming.
Yeah, just some.
So also, you can there are two ways. You can create the Java thread by yourself. Okay, we will see the example. Also, all the Java program process actually based on the thread program. Implicitly, they use the Java thread. So, for example, I'd like to make the Java programming to sum up the value, like the sum, and to do that. So, then next class is a summation. It's the implementation of the learnable. Okay, that's called the sum over there. And it's make the runnable. So you can create as many the sum as possible, then change the state. In your main object is a driver. Okay, you can create here the sum object, new sum that you defined the previous one. Okay, then you can create the thread over here. Then you can change the thread as a runnable. Then you can create as many as possible. However, sometimes you may not realize whether I'm using the thread in your operating system. That is implicit threading. So your operating system use thread. Sometimes even creating the thread takes a time. Anyway, it takes a time. It takes less time than the creating process. It takes a time. I need 1,000 of thread. Okay. To reduce such a creating thread time, we are going to create the pool of memory for thread. This is thread. It's ready. There is no data yet. Allocate the memory area for thread, user thread. Then if this one, there is a create the thread object, then point the available. This is called the thread pool. It's nothing but to reduce the creating time for better performance. So definitely this one is a faster, slightly faster, not drastically faster, but it's a slightly faster rather than creating the new thread. Okay. Also, you can specify the maximum number of the available thread the user application you utilize up to given number of the thread. Okay, so there is another thread programming. It's OpenMP. I never use. I know the OpenMPI is for the parallel programming, but I never use this kind of the similar approach. I'm going to skip this part. So Apple used the Grand Central Dispatch. It's for Apple. I think the Apple customize the thread programming. So is it always better than the creating process? No. So there are issues comparing to the book and EXCC. Okay, so we will talk about the rest of the part on Wednesday. Okay, I'm going to start today's lecture. Any question? What about the yes?
Regarding homework 2,
Homework 2. Yes.
yeah, we have some block of codes.
Mhm.
So we need to run it by our Windows machine, or I mean,
Doesn't
PC,
matter. Any available, so you can use
or
it.
I can also use my assumption, or I need to go to the machine.
Yeah, sure, no problem.
That's
Yeah. Any others? Okay, so we will see on Wednesday. So great issue.